This is Mrs. Kreider with just a quick tutorial for graphing points in the coordinate plane, finding their slope, and then using that slope to write the equation of another line that is parallel and also that is perpendicular. And we're going to do so in such a way that it passes through a specific point. This is from the Unit 1 activity. I'm going to go ahead and just graph 2 points, and we're going to select and draw the line that would pass through those points. This point is 1, 3. This point is 4, 4. Okay, so those clearly we can just take the 2 points and create the slope, but what I'm going to do is actually draw the line that would pass through them, because we're going to then map a parallel line somewhere else on the graph that passes through a different point. So for right now, here's the line that passes through these 2 points, and I know that I can find the slope using the slope formula. Okay, so the slope formula is y2 minus y1 divided by x2 minus x1. And I can go over here, and I find it helpful to label my x1, y1 and x2, y2 points like this. So for the slope formula, I would simply substitute the values 4 minus 3 divided by 4 minus 1. It's important to be able to do this because when you're doing slope work in this environment, you do need to actually be able to show those values plugged in, even though you can graph it and see with your eyes how to find the slope. This is 1 over 3, and what that means is for every 3 units of x increasing, I get 1 unit of y increasing. So, or I rise 1 for every run of 3. Okay, so rise over run means I go up 1, okay, up 1 unit, and then over 3 units, both in the positive direction, in order to get from any one point to any other. I could pick any 2 points on this line, and if I put them into the slope equation, I would find that the slope reduces down to 1/3 as the slope fraction. So what I want to do now is write the equation of a line that passes through some other point somewhere. And let's just for kicks use this point right here, 3, -1. So what we want to do is we want to draw or write the equation of a line that is parallel to this one, okay, parallel to this top line, but it has to pass through this point. Well, what we do know about this top line is that the slope equals 1/3. So if the slope here equals 1/3, then the slope for our new line will also equal 1/3. If that's the case, then I know a point and the slope. So I can use the point slope form of an equation. That looks like this. Y minus y1 equals m times x minus x1. Okay, so again, I'm going to label my points so that it helps me to plug everything in. We'll call this x1, y1. The y and the x are those standard variables that we use in any equation of a line. So those are going to stay as x and y. What I need to do now is substitute in the two things that I know, the slope and the point that it has to pass through. So the y value, I'm just going to carry down everything I know has to carry down. Okay, so there's a negative sign here. I'm going to bring that down, and I'm going to subtract the y value, which is a -1. Notice I drew this negative here. That will keep me from making the mistake of not addressing that sign change. So I'm going to subtract a -1, and then I am going to multiply by 1/3, which is my slope, and then x minus my x1 value, which is 3. Okay, so now I'm going to do a little bit of simplification. Y plus 1, because whenever I see two negatives, they do become a positive. And then I'm going to distribute this 1/3 to everything that's in the parentheses. So I get 1/3 x minus 1/3 times -3. I'm sorry, 3 over 1. That's a positive. I've already brought the negative down here. So that gives me y plus 1 equals 1/3 x. And then 1 times 3 is 3. 3 times 1 is 3. So that's going to be minus 3 over 3, which is the same thing as minus 1. Now I'm going to subtract 1 from both sides to get y by itself. And I get y equals 1/3 x minus 2. Now, if I am to plot these points using the same slope, I can just graph another couple of points, and I can actually see that when I draw my equation of my line, it does indeed pass right through -2 on the y-axis. which confirms that my intercept of -2 is correct, because this is now the slope-intercept form. So I can visibly see that my slope is 1/3 and that my intercept where it crosses the y-axis is -2. So I can graphically check and confirm what I'm doing. Okay, so now we're going to do a second example that involves drawing the equation of a line that is perpendicular to a line that we know the slope for and passes through a certain point. So here are 2 points in the line that passes through them. The points are 1, 2, and 3, 5. Okay, so the first thing we want to do is identify the slope of this line. So over here in my slope formula, y2 minus y1 divided by x2 minus x1, again, the change in the y or the rise divided by the change in the x or the run. So I'm going to again do x1, y1 and x2, y2 to label just to make it easier to substitute in. And then that's going to give me 5 minus 2 divided by 3 minus 1. So 5 minus 2 is 3, and 3 minus 1 is 2. My slope is 3/2, and I can confirm that by visually checking that from this point, I do indeed have to rise 3 units and run 2 to get from one point to the other. So visual confirmation. Now, we just need to identify another point that we need our line to pass through, and it's going to, let's put it just over here somewhere. We'll call this 2, -1. And visually, I can see what I want to do. I need to make a line that is perpendicular to my given line that passes through this point. So the first thing I need to do is identify the slope of a line that would be perpendicular to my given line. We know that slopes that are perpendicular, or slopes of perpendicular lines, have to be the opposite reciprocal. So if the slope of one line is 3/2, then the slope of a perpendicular line is going to be the opposite reciprocal. So my perpendicular line will have a slope of -2, 3. Again, I have the slope and I have a point. So I can use the point slope form of the equation to actually calculate out how to get my new line. So again, I'm going to label this as x1, y1, and I'm going to write my format right over here. And I'm going to start up a little higher so I have room to work my fractions. So y minus y1 equals m times x minus x1. That's my point slope form, and I'm going to substitute in everything I know. Y minus 2 equals -2/3 times x minus, oh, look what I did. And I had it all labeled and everything, and I called that 2. That should be y minus, you guessed it, -1. So make sure that you're consistently stopping yourself and checking that what you're doing is correct, because if I hadn't caught that, then my whole equation would have been wrong. So it's important to kind of give yourself a check and address as you go to make sure that you're doing these correctly. I catch myself in boo-boos all the time. Okay, so we're going to boom these negatives and make that y plus 1. And then let's go ahead and simplify this to the best that we can. We'll get a -2/3 x, and then since I'm multiplying negative times negative, that's going to become a positive. And I'll go ahead and show you that multiplied out. 2/3 times 2/1. And then we'll bring it down. Y plus 1 equals -2/3 x plus, and then since I'm multiplying fractions, I multiply the numerators and then the denominators separately. So that's going to be 4 on the top and 3 on the bottom. Okay, now we're getting into a little bit of a crazy time, because I am going to need to subtract this 1 from both sides of this equation, but I have 4/3 and I have 1, and that's going to be hard for me to simplify unless I do some fraction work. So let's clean it up the best we can. Y equals -2/3 x plus 4/3 minus, and we need some number here that is going to have a denominator of 3, but that still has a total value of -1. Okay, so I'm going to come over here and show you kind of the way I learned when I was in grade school is if I want a fraction that has a denominator of 3, sorry, I'm not changing 4/3, I'm changing the 1. I need a -1, and I'm going to put that over 1 because any number can be divided by 1 so that it looks like a fraction. and I'm going to multiply that by some what I call magic 1 number that has a 3 on the bottom. And since 3 on the bottom, to make that 1 has to have 3 on the top. So I can multiply any number by a fraction that has equivalent of 1, and I can use that to convert to whatever denominator I want. So when I multiply these across the top, I get negative 3 over 3. And common sense tells you, hey, that's negative 1 because negative 3 divided by 3 is negative 1. So this still has the value of negative 1 that we want. So we want to subtract 3 over 3, and that's the equivalent of subtracting 1. Now we can clean this up, and we get y equals negative 2/3 x. And then 4/3 minus 3/3 can be subtracted now because they have the same denominator. So that's going to be plus 1/3. And I can visually check that if I plot a point at about 1/3 of the way up the y-axis here, and then go ahead and draw my line that would pass through, then it should be something like this. And there you can do your quick visual check to say, hey, that actually does look perpendicular. And it does pass through this point 1/3, which confirms that my intercept is correct when I have it written in slope-intercept form. So these are just a couple of examples for you. One example that involves writing the equation of a parallel line, and one that involves writing the equation of a perpendicular line. Hopefully you'll find this